Assalamualaikum and a very good day. My name is Yusrina binti Azizan from 4 BEKGS2. In this video, I will explain about my final year project, which is load forecasting based on neural network approach. So this is the project outline. In this video, I will tell about the introduction, problem statement, objectives, scope of work, literature review, methodology, preliminary analysis, and conclusion. So first, introduction. What is load forecasting and what is neural network? Okay, so first I will explain about load forecasting. Load forecasting is a process of predicting the future load demands. It is important for power system planners and demand controllers. Electrical utility company in Malaysia will generate electrical energy based on the demand, as the electrical energy cannot be stored. Therefore, it is important to know how many electrical energy should be generated so that it will not be excessive and it will not go to waste. Next, neural network. So neural network is what we use in this project. It is a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. It is composed of many neurons that cooperate to perform the desired function. There are many types of neural network, which such as recurrent neural network, artificial neural network, convolution neural network, and etc. But in this project, I use recurrent neural network to forecast the load demand. So this is the problem statement in this project. So the problem statement is the electric power load and electricity demand forecasting are the most important tasks of electricity engineering. Accurate analysis of such points will enable the determination of conditions for sustainable energy supplement. However, electrical energy cannot be stored, as I mentioned earlier. It needs to be generated whenever there is a demand for it. Thus, imperative for the electric power utilities that the load on their system should be estimated in advance. This estimation of load is known as load forecasting. So the objective of this project are: first, to pre-process the electrical load data for a period of 2 months taken in Peninsular Malaysia. Next, to forecast the load data via neural network approach, which is the long short-term memory LSTM technique. And lastly, to identify the best long short-term memory structure that give the least error and predict accurately. So these are the scope of works in this project. Firstly, to forecast the load usage in future using neural network approach, which is long short-term memory LSTM. Next, the period of electrical load data used for training the LSTM is only 8 weeks collected from Peninsular Malaysia. Lastly, the focus generated by the LSTM are compared with the result of traditional methods using RMSE and MAPE. RMSE is root mean squared error and MAPE is mean absolute percentage error. We will calculate the RMSE and MAPE and to see whether how accurate the forecasted data is. Next, we will move on to literature review. In literature review, I will talk and explain about load forecasting and long short-term memory. For load forecasting, there are 3 categories of load forecasting method. First, short-term load forecasting. Short-term load forecasting is to forecast load for 1 hour to 1 week. Next, medium-term load forecasting. Medium-term load forecasting is used to forecast a 1 week to 1 year of forecasting load data. Next, long-term load forecasting. This is for more than 1 year. So in this project, the load data that we use to forecast is 8 weeks, which is medium-term load forecasting. Next, techniques of load forecasting. There are traditional forecasting technique, modified traditional technique, and soft computing technique. Soft computing technique is the most recent technique. It's more advanced than the other previous two. So neural network is under soft computing technique. We use neural network because it has the ability to learn and it offers the potential to overcome the reliance on a functional form of a form model. As I mentioned earlier, there are many types of neural networks. These are some of the types of neural networks used in previous studies. There are perceptron, feed-forward neural network, multi-layer perceptron, convolutional neural network, recurrent neural network, which is what we use in this project, and sequence-to-sequence model and modular neural network. We choose recurrent neural network because it is the most suitable for this project. Next, I will explain briefly about long short-term memory, LSTM, which is what we use in this project. LSTM is a special type of recurrent neural network, RNN. It is capable of learning order dependence in sequence prediction problems. It can process entire sequence of data and is designed to avoid the problem of long-term dependencies. Next, I will explain about the methodology in this project. So this is the flowchart of the project. We start with literature review and then data pre-forecasting, and then we move on to develop the model of long-short-term memory neural network using MATLAB, and then we observe and analyze the LSTM structure, and if this LSTM structure is acceptable, then the project is complete. But if the LSTM structure is not acceptable, then we have to develop the model of long short-term memory using MATLAB again and proceed to next step. So basically, this is the long short-term memory structure cell. By using MATLAB, the structure of LSTM will be modeled. The structure is then being trained with some training data. Then, the structure will be tested to see the accurateness of its forecasted data. There are three important parameters will be specified in the structure, which are epoch, hidden units, and weights. Epoch is an iteration through the process of providing the network with an input and updating the network's weights. Hidden units is the point where the current data is being stored, and the weights are modified to reduce the difference between the actual and desired output. Next is preliminary analysis. The collected load data will be classified and being compared based on the same day for 8 weeks, which means if Monday, we will compare every Monday data for 8 weeks. We compare the data for the same day because the load data for same day is almost constant from Monday to Sunday. So it is easier for the LSTM to forecast a more accurate data if we use the same day data for 8 weeks. As the conclusion, the training data will be taken from the same day for each week for 8 weeks, and LSTM methods allows the forecasting of load to be generated in future so that optimum amount of load could be produced. That's all from me. Thank you for your attention and thank you for watching.